Hello and welcome to this third and last part of the introduction to Exostiv. In this video we will demonstrate how to use the Exostiv dashboard analyzer to capture data from a running FPGA. The target board is up and running. You can see the blinking LED over here, and it is connected to the Exostiv probe that is also on, as you can see here. This is the Exostiv dashboard interface for the analyzer. That is the part of the software we use to control the probe and run some captures. So you see that we have many controls over here. First, you have one tab per capture unit. So you see that the IP configuration that you defined with the core inserter is reproduced over here. So you have the controls for each capture unit, and for instance here the controls for the selection of the data group connected to the system capture unit. You have some controls for the triggering, controls for the captures, the trigger positioning, the export, and a waveform viewer over here. What you see on the screen here are previous captures. So the first thing I'm going to do here is to connect my probe to my workstation through the USB. So I hit on the connect probe. It says it has found the probe on the USB, and I hit on connect. And you see that the first thing that it does is a piece of negotiation and detection. It has detected the probe over here. It is a probe with a 8 GB buffer, 4 lanes, 12.5 gigabit per second max. And right after this, based on the settings of the project, it is going to attempt to connect to an Exostiv IP located in the target design. And once it has found the Exostiv IP, it is going to try to establish a stable connection with the design under test, and you see that there is a quality link test, after which everything here down below has turned green. So we have the right IP in the target design that corresponds to the project. It is up and running, and we have a stable connection. So I'm going to proceed with the first capture. And for this, I'm going to select the first capture unit and, for instance, the sine wave data group. And I'm going to capture a very simple capture of exactly the size of the memory I have reserved in the capture unit. You see over here, in my first capture unit, I've got a 1K buffer. Well, I'm going to show you what 1K means as a capture. So I'm going to enlarge this and run one single capture of 1K and OK. So another one maybe. I don't use any specific trigger now. And you see that we have captured some data from this data group. This is indeed a bus on 16 bits. And when I represent that bus as an analog wave, it is a sine wave. And we have tuned that sine wave so that 1K sample is exactly one period of the sine wave. So what you see on the screen here is the quantity of data that you are able to store in the memory that's in the capture unit. And in other words, this would be what you could see if you use the JTAG-based logic analyzer like ChipScope or SignalTap or Xilinx ILA, and exactly the same footprint on the FPGA resources. Now we are going to see that Exostiv allows you to capture much more data. I'm changing some settings over here, and I'm going to capture not 1,000 but 5,000, 50,000, 500,000, 5 million samples. And so there we go. So now I've captured 5 million samples, and this is the result I have. And if I zoom in, you see that I've got indeed that same sine repeating pattern. And in this case, I've been able to stream my data out to the external memory, and this is what you see over here. This is what you can store in the capture unit, and of course with Exostiv you can see much more. So let's say that somewhere in this data stream I've got a random event, and of course a random event is very difficult to catch usually because you just can't put any trigger on it. So I can tell you there is a random glitch somewhere in the sine wave, and I'm going to look for it, and you see I found it. So this is inserted on purpose, but I don't know where it is going to be inserted. And you see that one of the huge advantages of using Exostiv to catch such things is that when you enlarge the observation window, then at the first run you are certain to have captured what you are looking for. If you had to catch something random like this with such a small window, there are chances that you are going to miss it most of the time. Whereas here, and of course here this is very visual, yes, here there is another one, you are absolutely certain to capture such random events. Like I said, in this case, this is for the demonstration. It is very visual. We are able to catch it just by looking at the waves. But this waveform viewer is also able to export the waves that you select to different formats, and from those formats you can proceed with an analysis with another algorithm, for instance. Another possibility is to directly export your capture as a raw sample, and you can even disable the waveform viewer so that you can collect databases of captures from your running FPGA. And a last capability is also to use the console. We have a full scripting interface in Exostiv dashboard, so anything that you can do with a graphical user interface is something that you can do with the console. So that's the first demonstration of how useful enlarging the capture window can be. But as that's not the end of it, I'd like to switch to the second capture unit where we have this video interface. And if I run a very simple capture, you will see that in this window we have captured data. This is a video interface, so we have the red, green and blue components of a video flow. We have a line counter, blanking, start of frame and valid, so very traditional kind of signaling. So here I'd like to show you how we can run a very useful interrupted capture with Exostiv. And let's say that I'd like to see some data at the beginning of the next 500 frames. You see, you select the signals that you want to react on, and here I've added the start of frame signal, so that's the beginning of each frame, and I say, like, look, I'd like to detect the falling edge of the start of frame, and each time I do this, I'd like to capture 25, well, let's say 26,000 samples, and position my trigger somewhere in the middle of this window, and I'd like to do this for the next 500 frames. So here I'm going to run a repeating captures 500 times, detecting the start of frame signal of the video flow. Each time I detect it, I capture that amount of data, positioning the trigger over here. As I run the capture, please pay attention to this progress bar over here, because you will see that we will be capturing as I speak. So it means that from the start to the end of the capture, you will have seconds, minutes, not just a few milliseconds or microseconds, really something that starts at one moment and ends after a few seconds or minutes later. So we are extending the reach over the timeline of your FPGA and are really watching the FPGA as it runs, but during extended times, I would say. I'm running the capture now. You see, we have captured 100 frames, 200, and so on. So it's capturing as I speak. And now it is going to take some time to download the waves to the waveform viewer. Some post-processing, and there we go. So we have captured 500 times this amount of data on those bits, so that's quite a lot of data. And by the way, this waveform viewer is unique in the sense that it is able to process a gigabyte or even terabytes of data. So you see the full capture over here. So you see I've zoomed in, and we have those gray and black areas over here. Each of them represents a chunk of data of 25,000 samples with a trigger in the middle. So let's have a look. We should have 500 of them. So if I zoom to the end, you see that this is trigger number 500. And if I zoom onto a single zone like here, we should have 25,000 samples with 13,000 before the trigger and the rest after it. And so I'm zooming out, and you see that here we have on this scale, negative scale, 12,000, 13,000 up to here, and the rest after it. And the trigger should be on the falling edge of the start of frame, which is the yellow signal over here, and you see it's indeed positioned on this signal. So a lot of capabilities to run interrupted capture, but there is more. I've spoken about data qualification, for instance, and say that during this debug, verification, or test scenario, you are just interested in looking at what happens in line 2D of the frames. Then we would like to filter out the data on this condition. So what we are going to do is use the data qualification. You switch the tab, add a sensitivity on the line counter, and say, look, I only want to capture data when this condition is true. So in this case, I'm running it again, and if I zoom out, you see that I've indeed captured data only when the counter is at value 2D. And that happens upfront in the Exostiv IP. And of course it is very convenient because you focus on what's interesting only, and it reserves the available bandwidth and memory for useful data. Well, this is pretty much what we wanted to show to you about Exostiv in this brief introduction and demonstration. Exostiv provides you with unprecedented visibility in the gigabyte range, and the bandwidth that is required to really extract that kind of data quantity out of running FPGAs. I'd like to thank you for your attention and hope to hear from you very soon. Bye-bye now.